Dear students, we are going to discuss about the vortex in the agitation process. The vortex is nothing but the swirling of the fluid around the shaft, around the agitator. So that is nothing but the flow is rotating around the axis line. So you can see the fluid which is simply rotating around its axis, and that is what the vortex that will be there. Now in this case the generated vortex that goes up to the bottom section you can see in this figure, the generated vortex is up to the bottom section of this vessel. And here also it's up to the impeller only, the fluid that moves in the upward direction, and the gap or the air that will be available up to the impeller in this flow. Because if you look at the flow pattern, the fluid simply swirls around, rotation of the fluid that will be observed. And because of this centrifugal force the fluid moves towards the outward section. आप कंटिन्यूअसली रोटेट करते जा रहे हो तो रोटेशन के कारण फ्लूइड को आउटवर्ड मूवमेंट, आउटवर्ड फोर्स एक्सपीरियंस होता है। आउटवर्ड फोर्स एक्सपीरियंस होता है तो फ्लूइड ट्राई टू मूव इन द गो इनटू द आउटवर्ड डायरेक्शन एंड it moves in the upward direction, and that is why this rise in the level it can be observed towards the wall because of the centrifugal force which is provided by the rotatory movement of the impeller. So mechanical energy converted from electrical energy to mechanical energy of the rotation of the agitator, from mechanical energy of the rotation of agitator to the swirling or movement for the fluid, and this movement of the fluid centrifugal force acts on that and it rises in towards the wall. So this is this is the disadvantages. The vortex formation is the disadvantages. It's simply wastage of energy and without proper mixing. So to prevent the vortex formation, baffles on the tanks that is used, or the impellers in an angular off-center position that will be used. And when the direction and the velocity of the flow of the suction of the impeller are to be controlled, the draft tubes are also sometimes used. So the baffles, off center position of the impeller, and the use of the draft tubes that will be there. The baffles on the tank wall, this is the most common thing that you can observe, the baffles provided with the vessel wall. So you will look at this figure, the baffles they are nothing but your vertical plates welded to the vessel wall at four different places towards in a 90 degrees angle. So it if simple swirling motion is required, no baffling is necessary. The generating four baffles is usually located 90 degrees apart. The baffle width that is generally 10 to 12% of the diameter, vessel diameter, 10 to 12%. Whereas in case of your 1 meter diameter, it's a 10 centimeter baffle that can be used. The baffle height is generally two times the impeller height. Then with the coils in the tank, the baffles are placed inside the coil. So that precaution has to be taken. Then without baffles, the tangential flow occurred. Without baffle, the tangential flow, that is the swirling occurs in a mixing tank, causes the entire fluid mass to spin, and because of the centrifugal force. With the baffles, most impellers show their true flow characteristics. Most common baffles are straight flat plates of the metals, and four plates are generally used. Now the next is the impellers in an angular off-center position. That is the position of an impeller, the mounting you can say. The mounting the impeller away from the center of the vessel and tilted in the direction perpendicular to the direction of the flow. So that helps to prevent the vortex formation. Without the buffer, the tangential flow occurs. Mixing tank causes the entire fluid to mass spin. So these are the off-center positions you can see in this figure. Off-center position with a central tilted buffers, and the generated flow patterns will be like this. And then it is the off-centric position. Again, generated flow patterns are of the different type. So because of the baffles, now in this figure, B figure and A figure, the draft tube that will be provided. Draft tube that helps to move the fluid in the downward direction, and around the draft tube also. In between the annular section, that is nothing but the section between the outside of the draft tube and the inside of the vessel, the loops that will be generated. So these are the simple vortex formation, and which is to be avoided. Besides that, this generated vortex that is also going to cause the cavitation if you are going to apply the pump, or the generated bubble. It sucks the air inside that, and as it sucks the air pockets, they will hammer your impeller. They will hammer the impeller, and this continuous hammering of these air pockets or air bubbles, that is going to deteriorate or destroy your impeller. The quality itching of that impeller that will be observed, erosion that will be observed, and so continuous hammering of this hammering of these air pockets or the uh, air pockets, that is going to damage your impeller quality. So that is to be avoided by providing the baffles, because providing the baffles is very simple, and that helps to reduce the vortex formation and prevent the damage to the impellers.